Hello and welcome to Physixify. Once again, we are doing problems in work energy theorem, right? We have problems part 2, so some extra problems for you today. Let's start it up. Question number 5, continuing from the previous video, we are saying that there is a variable force F given to us that is displacing a very small mass M slowly, very gradually by an angle theta, and you have to find the work done by this force. Now if you see, this is the force that is being applied. We are being told that this is a variable force. This is already given in the question, and it is applied in such a way that we take this mass from here to here. Now you have to tell the work done by this force. A similar sort of question we have actually done earlier, and we are given some 4 options as well to answer. Now how do you do it? Since this is a variable force, this is not a constant force, which was actually the case once we did earlier. So how do we proceed in this? What we say is that first of all, if it is going very slowly, right, it is also given, it is going very slowly, it is going gradually. This means that there is no change in speed, there is no change in velocity, which means if initially it was at rest, it's gonna remain at rest finally as well. This means your initial and final kinetic energies are equal, and that means work done by all the forces, which was equal to change in kinetic energy corresponding to work energy theorem, this turns out to be 0. And once you have come from here to here, once you've seen that work done by all the forces is 0, things become a little more easy for you. Why? If you can see all the different forces, you can add all the work done and you can say that this net work done is 0. Now what are the forces that will act? I will say there would be a force mg acting downwards, that is the gravitational force. Next thing, there is always going to be a tension force. If the block is or the mass is here, the tension would be this side. There would be a tension that would be coming all the time, and there is a force F. So there should be 3 types of work done due to 3 forces that we must write for this mass. So that is exactly what I'm gonna write. I'm gonna write W of mg plus W of t plus W of f must be equal to 0. Now what can we do? First thing that I will say is that work done by tension is 0 because t is always perpendicular to small little displacements that would be happening. If I go initially, I'm going to go like this perpendicular to t. If I am here, t is here, I'm going to go like this perpendicular. So all the times I can say t is perpendicular to the displacement, and that is why work done due to tension is 0. If I remove all of these small little things, next thing that I will say corresponding to mg, right? Now I'm going to do this corresponding to mg. What I'll say is that overall this is the displacement that I have. How much is this? See, overall this much is L. It is already given. If this is also L, I can say this much length would be L cos theta. So obviously this remaining length becomes L minus L cos theta, right? And once you have seen that this is the displacement, mg is downwards, L minus L cos theta is upwards. So the next thing you'll say is W due to mg turns out to be minus mgl times 1 minus cos theta. W due to tension turns out to be 0, and W due to F, that is what is being required by you, can be calculated after you equate it to 0 using work energy theorem. Right? A little tough, a little much to think, but again, I hope that once you've seen these questions, you would be able to mark these questions in the paper as well. So final result that we get is work done due to force becomes mgl times 1 minus cos theta. I hope this is done fairly. Let's go to next question. First of all, we'll just mark off this option, that D option over here turns out to be correct. And going to question number 6 now. What is given to us? We are being told that there is a ball of mass 5 kg. We drop it vertically. Dropped means your initial velocity is 0. You drop it vertically through a height of 20 meter. You fall down 20 meter and it gains a speed of 10 meter per second in the downward direction. At that point, you are being asked overall what would be the work done by gravitation force and what would be the work done by air friction. So what I will say is that if my ball is falling, initially if this 5 kg ball I want to take, initial velocity turns out to be 0. Now if it falls through 20 meter, you are being told that now the velocity is 10 meter per second. So you are given initial velocity, you are given final velocity. We get a feeling that we can use that work energy theorem because change in kinetic energy is given. But how do you calculate the work done by gravitation force and air friction? So gravitation force is quite easy. You will say that if I want to see this force, I can say that this is my force due to gravity, mg 5g, you can say 50 newtons if g is 10 per se. And next thing you can say is that work done by gravitation, since this is a constant force, you fall down 20 meters in the same direction, that is mg, that is downwards. You will say that mg into s, that is 5 into 10 into 20, this 1000 joule turns out to be your particular work done due to gravitation force. But still we want air friction. Now what we can do? Now we can use the work energy theorem. So if you use this, you'll say work done by all the forces equals change in kinetic energy. Obviously there are two forces. One is gravity, that is weight, that is taking you down, and the second one is air friction. So you can say Wg plus W air friction is change in kinetic energy. You know the change in kinetic energy is half into m into this Vf square minus Vi square. So this would be half into 5 into 10 square. Your work done due to gravity, already you calculated 1000. So your work done due to air friction turns out to be minus 750 joules. Right? This is how we proceed, step by step. I hope this was clear. Next question, if we take question number 7, what is being told to us? Now this is a little different question. Force is given in vector form. You might be thinking about conservative and non-conservative force. Don't right now. Let's read this question. A force is given 2I plus 4j acts on a body with a mass 10 kg, displaces it from a point 1, 1 to a point 4, 2. Initial velocity was given 2 meter per second. Final you have to find. Now there are a lot of ways to do this question. A lot of people might be tending to do this with kinematics, but let me explain it to you through work energy theorem because that is what we are seeing right now. So what I'll say is that let's try to use that theorem. But first thing that I would see is that if I want to calculate the work done, the force is given in vector form, let's get the displacement in vector form as well. That is exactly what I've done in this first part. That your r vector, that is displacement vector, is r2 minus r1, that would be 4i plus 2j minus 1i plus 1j, that would be 3i plus 3j. Now you use your work energy theorem that work done by all the forces equals change in kinetic energy. This work done can be written as F dot R. Change in kinetic energy can be said to be half m Vf square minus Vi square. Again, I've taken it in brackets, common half m. I hope that's not a problem. You have done so much of these questions. So the next thing is, once you do F dot R, that is 2i plus 4j dot 3i plus j, this thing will turn out to be 2 into 3 would be 6, 4 into 1 would be 4, and this would be 10. Obviously this 10 and this 10 would cancel out. You'll get Vf square minus 4 as 2. So Vf would be under root of 6. So that is your final velocity. I hope that all these questions were clear to you. Here's a question that you can attempt. Let me know your answer in the comments and we can discuss that probably going next lesson forward. Right, I would be waiting for you. I hope you did like this video. Please make sure that you subscribe as well if you don't want to miss anything. The link for the grams, that is Instagram and Telegram, are given in the description. Do check out those links as well. And if you have any other problem that you faced, please write it down in the comment box. We always want to go onwards and upwards. See you later.